Ms. Lopez, the kindergarten teacher, is planning a treasure hunt for her students. So she drew a model of the playground on a coordinate plane as shown, and she used this model to decide where to place items for the treasure hunt, and to determine how to write the treasure hunt instructions. Each grid square represents 1 squared yard on the playground. So, determine the distance in yards between the merry-go-round and the slide. Okay, so merry-go-round and slide, the distance, we can just count by yards. 1, 2, 3, 4, 5, 6, 7, 8 yards. Right? Or 11 minus 3. Because this is at 11, this is 3, 8 yards, right? So when they say show your work, either counting or 11 minus 3. Now Ms. Lopez wants to place a small pile of beads in the grass halfway between the merry-go-round and the slide. So how far in yards should the beads be placed from the merry-go-round and the slide? Well, if they're 8 yards apart and you want to go halfway, they should be placed 4 yards apart. And then they want to write the coordinates for the location exactly halfway between. So that's 1, 2, 3, 4, right here, right? And that's 1, 2, 3, 4. So the coordinates are 7, 2. And then graph the location of the beads on the coordinate plane right there, right? So how do the coordinates of the location of the beads compare to the coordinates of the location of the slide and the merry-go-round? Okay, well, notice that this point, we said that's 7, 2. This one right here is 11, 2. This one right here is 3, 2, right? So obviously the 2's are all the same. The y values are all the same because they're all on a horizontal line. But the x values, the 7 is halfway between 11 and 3, right? So you could say 7 is halfway between the 11 and the 3. Or you could say that really halfway between something is always the average. If you added 3 and 11 and then divided by 2, you would get halfway between, right? 3 plus 11 divided by 2, that's 14 divided by 2, 7, right? So this is another way to think about how the 7 compares to the 3 and the 11. Halfway between, well, part of how to find halfway between is just to add up and divide by 2. Okay, so 5, 6, and 7. So notice that 5 is about placing a pile of kazoos in the grass halfway between the slide and the swings. So slide and the swings, right? And then how do the coordinates of the locations of the kazoos compare to the coordinates of the location of the slide and the swings? So that's 5 and 6 you need to do on your own. Definitely do those on your own. But now here, Ms. Lopez wants to place a pile of buttons in the grass halfway between the swings and the merry-go-round. So here's that situation where we have a diagonal distance. So notice that things get funnier when we have the diagonal distances, just like the distance formula, right? So describe how you can determine the halfway point between those. Now if you notice, if I draw, they're suggesting draw some right triangles, right? If I draw some right triangles here, notice that this one, this right triangle, and this right triangle look about the same, right? And in fact, this one's 1, 2, 3, 4 on one side, 1, 2, 3, 4, 5 on the other. 1, 2, 3, 4 on one side, 1, 2, 3, 4, 5 on the other, right? So we know that if these right triangles are the same, then these distances must be the same. So this must be the halfway point, right? This must cut that in half. So if I go halfway between the slide and the merry-go-round, and I go halfway between the swings and the slide, and then I just draw up there, that's going to be halfway between the swings and the merry-go-round, right? So you guys write a sentence to explain that, right? Write a sentence to explain that. Now, we're actually going to skip from here. Number 8 on through is a lot of practicing the distance formula, which we just did in the last section. And we're not going to practice that, so we're not going to worry about 8. We're actually not going to worry about this entire page, not 9, not 9A or B, okay? We're not going to worry about 10. Again, this is a lot of practicing the distance, okay? Not 11, not 12. But what we are going to do is we're going to skip ahead to 14, okay? And the 14 refers to this diagram. They're trying to generalize, just like they did with distance formula, where you have the first point, right? And so you have some like x1, x2, y2, y1, right? Okay, so notice that what they're doing here is they're using that diagram and they're saying this is the midpoint formula. So if you're trying to take 2 points and find the midpoint of them, what you do is like what we just said, you add the x values up and divide by 2, and that's the middle of the x's. You add the y's up and divide by 2. So this is a fancy way of saying just add x's up, divide by 2, add the y's up and divide by 2, and you have found the midpoint. And that's really all you had to do over here, right? Add the 3 plus the 11, that's 14, divide by 2, and that gets you at 7. That tells you the x coordinate, right? So use the midpoint formula to determine the midpoint between the swings and the merry-go-round. So the swings and the merry-go-round, remember? We just said 3 plus 11 and are the x's. So you say 3 plus 11 over 2, that's 14 over 2, that's 7. So this is the x value, right? And now we just need to do that with the y value. You would add, here this y value is 2 and this y value is 12, right? So add those two y values. Two plus 12 over 2. Add the two y values, 14 over 2, and that's 7, right? This is the y value. So it turns out that 7, 7. And if we check, notice that's exactly what we said. We said 7, 7, right? So the big thing with distance, remember distance was about how far apart they were. So we were subtracting before we used the formula. We're subtracting to find the distance. But here, midpoint is about the middle, the thing that's in the middle. And remember, to find the middle, you're just taking the average. You add and divide by 2 to find the average. So you can use the formula or you can use the idea. So do you think it matters which point is the first point or which point is the second point? Do you think that really matters in figuring out the midpoint formula? So you need to answer 15. And then we're just going to determine the midpoint of each line segment here. Okay, so you're going to do, sometimes it helps to go ahead and graph them. Technically, you can just plug it in the formula, but I think it helps to graph, right? So we kind of know what we're talking about. We've got the point 0.5. So that's right here. And then 4, 3. So we've got this segment right here. What's the midpoint? Well, I'm looking at it, and this pretty much looks like the midpoint, right? 2, 4, right? But this says, let's go ahead and just use the midpoint formula and see if our work is right. Remember, the midpoint formula says add the two x values, divide by 2. So that's 4 over 2, and that's 2. So this is the x. And for the y, add the two y values, 5 plus 3, divide by 2. That's 4. Is that what we said it was going to be? Yes, we said it was going to be 2, 4, just by looking at the graph. So your job is to do B, C, and D. And one thing is, looking at a graph is a good way to check your answer, but if your midpoint happens at a decimal value, it's going to be hard to read that off a graph. So I really want you to try to use the midpoint formula down here, the way I just did right here, to make sure your answer is good. And then it's always a good idea to graph it just to check.